Today I'm going to be covering 13.3 notes, radian measure, day 1. So a radian is the measure of a central angle that intercepts an arc with length equal to the radius of the circle. So radians are just an angle measure. So do you remember how you can measure length in feet or inches or feet in meters, but it's still measuring the length? So in math, when we're measuring angles, we can use degrees or we can use radians. So it's just a unit to measure an angle. So we have the key concept here is we want to sometimes convert. Sometimes it's just easier to work in radians. So if I want to convert from degrees to radians, you're going to multiply by pi radians over 180. Or if I want to convert from radians to degrees, I multiply by the conversion factor 180 over pi. So we're just going to hammer these out. All you're going to do in this group to write in radians is you're going to multiply by pi over 180. So we're going to do these exact. That means no decimals. You should not be pressing anything on your calculator. So if I have 20 times pi over 180, 20 goes into 20 once, 20 goes into 180 9 times. So that's pi over 9, and I have converted to radians. Let's try the next one. If I want to convert 150 degrees into radians, the conversion factor is pi over 180. Here's kind of a simple way to remember, are you going to multiply by pi over 180 degrees or 180 degrees over pi? If you're trying to cancel degrees, you need degrees down in the denominator. All right, so now 150 and 180. How about, you know you can cancel out the zeros because you could divide by 10. So I could cancel the 0 in the top of 150 and the 0 out of the 180. I'm dividing by 10. Now, if I have 15 pi over 18, you do want to ask yourself, can I continue to reduce? So think about what number, what common factor is in 15 and 8? It's 3. So 3 goes into 15 5 times, 3 goes into 18 6 times. This is 5 pi over 6. Now I am in radians. I don't typically write out the word radians, but here's the rule of thumb. If you put a degree symbol next to your angle, it's degrees. If there is no degree symbol, it is assumed mathematically you're in radians. All right, so let's try the next one. So 45 pi over 180. So I know that 5 goes into 45 9 times. 5 will go into 180 36 times. So that's 9 pi over 36. And ask yourself, can I reduce that? Well, 9 goes into 36 4 times, and 9 goes into 9 once. So this would reduce to pi over 4. Go ahead and pause the video here and try 4, 5, and 6. When you're done trying it yourself, then press play. So I'm still converting from degrees to radians, so I'm going to take negative 110 degrees times pi over 180. Well, they both end in a 0, so that means I can divide by 10, and I get a negative 11 pi over 18. Now think about what we talked about with angles, and we were sketching angles in standard position. A negative angle is a clockwise rotation. So that's what I have there. All right, 315 degrees times pi over 180. I happen to know that 45 degrees goes into 180 4 times. 45 degrees goes into 315 7 times. If you can jump with me and do 45 into each number, that would be great. If not, start with 5 and then keep going. Number 6, 320 degrees times pi over 180. Divide by 10, so that'll give you 32 pi over 18. And then what number goes into both 32 and 18? They're both even, so let's start there. So that gives me 16 pi over 9. So before I continue, let me just recap. A radian is just a measure for a central angle. Now it's a special one where the radius and the intercepted arc are equal. But think of it like degrees measure an angle and radians measure an angle. To convert from degrees to radians, we multiply by pi over 180. That's degrees to radians. If I want to convert from radians to degrees, I multiply by 180 over pi. So let's flip the page. And it says, write each measure in degrees. Now when you look at 7 through 12, I want you to notice there's no degree symbol. That's how I know it's a radian measure. So I'm going to need to take negative 3 pi over 2, and I want the radians to cancel, so I need to multiply by 180 over pi. So the pi's cancel, and then guess what? 2 can go into 2 once, 2 goes into 180 90 times, and I'm left with degrees. So that's negative 270 degrees. So this is actually not bad at all. 5 pi over 3 is radians, because there's no degree symbol. I want degrees, so degrees are going to be in the top. So I'm going to multiply 5 pi over 3 times 180 over pi. I can cancel the pi's, and then 3 goes into 3 once, 3 goes into 180 60 times. 5 times 60 is 300 degrees. All right, pi over 12, I'm going to multiply by 180 over pi. My pi's cancel. I get 180 over 12, and that actually cancels perfectly to 15 degrees. Pause the video again and try 10, 11, and 12. When you're done working on your own, and please, please pause the video and try this. If you just copy me, you're not going to know how to do this. When you're done trying, then press play. So I multiply by 180 over pi. The pi's cancel. 5 goes into 5 once. 5 goes into 180 36 times. 8 times 36, 288 degrees. Number 11, negative 7 pi over 6. I want to convert to degrees. So I multiply by 180 divided by pi. The pi's cancel. 6 goes into 6 once. 6 goes into 180 30 times. This is negative 210 degrees. 9 pi over 2. Multiply by 180 over pi. Cancel the pi's. 2 goes into 2 once. 2 goes into 180 90 times. That's 810 degrees. So, if you want to convert from radians to degrees, you multiply by 180 over pi and reduce. All right, last topic here is we're going to do what we did the other day. What if I want to find cosine of theta and sine theta, but the angle is in radians? What you can do is simply convert. Negative pi over 6 is radians. Convert it to degrees, and then you do the exact same thing. 6 goes into 6 once, 6 goes into 180 30 times. That's negative 30 degrees. So what you're going to do So this is really nice. We've just added one layer to this. Convert your radians to degrees, and then watch. I'm going to sketch this. This is a 30-degree rotation. So it's a 30-60 right triangle. The hypotenuse is 1. Across from 30 is 1/2. Across from 60 is radical 3/2. Now stop and think about left and right. So this is right is positive, down is negative. So cosine, and it's -pi/6. SOHCAHTOA is adjacent over hypotenuse. So it's radical 3/2. Sine -pi/6 is -1/2. All right, number 14, 3pi/4. So do 3pi/4 times 180/pi. Just because of time and space, take a moment, reduce it. So pause the video if you need. I got 135 degrees. 135 degrees is going to be in the second quadrant, and it is exactly halfway. So this is a 45-45 right triangle. So this is radical 2/2, radical 2/2. I went left, so that one's negative. So cosine 3pi/4, SOHCAHTOA is adjacent. So it's negative radical 2/2/1, the hypotenuse. Sine 3pi/4 is radical 2/2. I am doing these very quickly because we've already learned how to do it in degrees, so this is not new. -pi/3. I multiply -pi/3 times 180/pi. The pi's cancel. Reducing is -60. A negative angle rotation is clockwise. It's going to go down here, and I'm rotating 60 degrees. The hypotenuse is 1 because we're making a unit circle. That's the radius of the circle is 1. Across from 30 is 1/2. Across from 60 is radical 3/2. You're supposed to know that now. You've got maybe a slip of paper with the triangles on it, your special right triangles. Right to the 1/2 is positive, down is negative. So the cosine of -pi/3 is adjacent over hypotenuse, so that's 1/2. And the sine of -pi/3 is negative radical 3/2. All right, what I'm going to do just for time, I'm going to you pause the video and do 16, 17, and 18. I am just going to put the answers down. And you see if you can figure out how I got these. So you'll have a whole lot more work than I do. I'm just jotting the answers down. All right, that concludes 13.3, day 1.